In the summer of 1938, a German painter and amateur archaeologist named Wilhelm König was working in the basement of the Baghdad Antiquity Administration when he picked up a small clay jar that had been sent in from a recent dig site outside the city. The jar was unremarkable, about the size of a wine glass, dated to roughly 2,200 years ago. König turned it over in his hands. He noticed that something was sealed inside it. He pried the lid open. And what he found made him put the jar down very carefully on the table, because he understood, in that moment, that he might be looking at the oldest electrical device in human history. I'm going to walk you through 3 things in this video. The exact construction of the jar König found, and the 4 specific features that, taken together, make it look unmistakably like a deliberate electrochemical cell. The 1970s replica experiments, the moments when modern researchers built copies of the Baghdad device, filled them with materials that would have been available in ancient Mesopotamia, and measured a real, working electrical current. And the alternative explanation, the mainstream archaeological reading that says the jars were not batteries at all, and the specific question that explanation has never satisfactorily answered. Stay with me. Because the simple test that would settle this debate has been performed dozens of times. The result, every time, has been the same. The site is called Kujut Rabu. It is a small village a short distance southeast of Baghdad, on a stretch of land that has been continuously inhabited since the 3rd millennium BC. In the 1930s, the area was being surveyed and excavated by Iraqi and European archaeologists working under the supervision of the Baghdad Antiquity Administration. Wilhelm König was not a trained archaeologist. He had come to Iraq in the 1930s as a painter and decorator. He developed an interest in ancient artifacts, learned the basics of conservation, and was eventually appointed head of the Antiquity Administration's laboratory, a role that involved cleaning, cataloging, and preserving objects sent in from field sites. In 1938, a small clay jar arrived from a site near Kujut Rabu. The jar was about 13 centimeters tall. It was made of an ordinary terracotta, the standard pottery material of the region for several thousand years. By external appearance, it was nothing remarkable. Hundreds of similar jars from the same period sit in museums around the world. But this one was sealed. The mouth of the jar had been closed with a plug of bitumen, a tar-like organic material that the ancient Mesopotamians used as a waterproof sealant. König carefully removed the bitumen plug. Inside, suspended within the jar, he found 2 objects. The first was a copper cylinder. It had been rolled and soldered into a tube shape, open at one end, closed at the other, occupying most of the interior volume of the jar. The copper had been worked carefully, the seam was clean, the cylinder was cleanly fitted to the jar's interior. The second was an iron rod. It was inserted down the central axis of the copper cylinder, suspended within it but not touching it, held in place by another plug of bitumen at the top of the cylinder. So what König was holding was a clay jar containing a copper tube, with an iron rod suspended inside the copper tube, with both metal components insulated from each other by an organic plug, with the entire assembly sealed inside an outer ceramic vessel. That is not the structure of a storage jar. It is not the structure of a religious offering. It is not the structure of a cosmetic container or a wine vessel. It is, in modern terms, the structure of a primitive galvanic cell. A galvanic cell, what most people would call a battery, works on a simple principle. You take 2 different metals. You suspend them in a conductive liquid called an electrolyte. The 2 metals react chemically with the electrolyte, and because they react at different rates, electrons flow from one metal to the other through any wire connecting them. The metals must be different. Iron and copper work well, they have a known voltage potential of roughly half a volt when paired in a typical electrolyte. The metals must not touch each other directly. They have to be insulated, so that the only electrical path between them runs through the electrolyte. There must be a way to introduce the electrolyte. The vessel must hold liquid. Look at the construction of the Baghdad jar. 2 different metals, iron and copper. Insulated from each other by bitumen plugs. Held inside a ceramic vessel that easily holds liquid. Sealed at the top in a way that prevents evaporation, allowing a long-lasting reaction. Every structural feature required for a working galvanic cell is present. There are no superfluous features. There are no missing features. If you handed the same set of materials to a modern electrochemist and asked them to build a battery, they would build something very similar. König published his hypothesis in 1940. He proposed that the jar had been used as a galvanic cell, possibly to electroplate gold onto silver objects, a technique known to have existed in the ancient Middle East. He could not prove it definitively, but he made his case in print, and the question entered the academic conversation. Then the Second World War happened. Iraq became inaccessible to European researchers for years. The jar, and several similar jars later found at the same and nearby sites, sat in storage, mostly forgotten, until the question was revived decades later by a different team of researchers. In the 1970s, an Egyptologist named Arne Eggebrecht, then director of the Roemer und Pelizaeus Museum in Hildesheim, Germany, decided to test König's hypothesis directly. He commissioned a working replica of the Baghdad jar, built to the same dimensions, using the same metals and materials. He filled it with grape juice, which contains tartaric acid, a natural electrolyte that would have been readily available in ancient Mesopotamia. The replica produced a measurable electrical current. Roughly half a volt. Stable. Sustained. Eggebrecht then performed a second experiment. He took a small silver statuette and connected it, by wire, to the replica jar. He suspended the statuette in a solution containing dissolved gold. The current from the jar carried the gold ions through the solution and deposited them onto the surface of the silver, producing a thin, uniform layer of gold plating. In other words, the replica did exactly what König had hypothesized: it electroplated gold onto silver, using only materials that would have been available in 250 BC. Subsequent replications have been performed multiple times, by independent researchers, by university labs, and most famously on the American television program MythBusters in 2005, which built 10 replica jars connected in series and produced enough current to deliver a measurable electric shock. The pattern is consistent. Every replica, every time, produces working electricity. The construction works. The principle is sound. The materials are available in the period. This is not in dispute. So I want to give you the mainstream archaeological reading honestly, because it deserves serious engagement. The standard view today is that the Baghdad jars were not batteries. They were storage containers, specifically, containers for sacred scrolls. Papyrus or parchment scrolls, rolled tightly, would be inserted into the copper cylinder. The iron rod, the bitumen seal, and the outer ceramic vessel would protect the scroll from moisture, insects, and light, allowing it to survive for years or centuries. Several similar containers, used for exactly this purpose, have been found at other sites in the region. The interpretation is plausible, internally consistent, and supported by physical parallels. There is just one problem with it. If the jars were scroll containers, they would have contained scrolls. Or fragments of scrolls. Or organic residue from decayed scrolls, the chemical traces that papyrus and parchment leave behind when they break down over millennia. The Baghdad jars do not contain scrolls. They do not contain scroll fragments. They do not show chemical evidence of degraded organic writing material. What they do show, on the inner surface of the copper cylinder, is a corrosion pattern consistent with prolonged exposure to a mildly acidic liquid. Vinegar. Wine. Fruit juice. The exact substances that would function as an electrolyte in a galvanic cell. The mainstream explanation accounts for the construction. It accounts for the materials. It accounts for the parallels with other regional scroll containers. But it does not account for the corrosion pattern. And it does not account for the most basic question: if the jars were scroll containers, why are they empty, and why do they show signs of having held acidic liquids instead? There is no good answer to that question. So what do we do with this? We have a 250 BC clay jar with a construction that, by every functional test, works as a battery. We have replica experiments that consistently produce electricity using period-appropriate materials. We have corrosion patterns inside the original jars that are consistent with electrolyte storage and inconsistent with scroll storage. And we have a mainstream alternative explanation that does not fully account for the physical evidence. The honest answer is that we do not know, with certainty, what the jars were used for. They may have been batteries used for electroplating. They may have been used for medical applications. There is some evidence that mild electrical shocks were used for therapeutic purposes in the ancient world. They may have been used for ritual purposes that we do not have records of. Or they may have been something else entirely, used for a purpose that has left no surviving documentation. But notice what we can say with confidence. Whoever built the Baghdad jar, whether by accident or by design, produced an object that, when filled with the right liquid, generates electricity. The construction is too specific, too precise, and too consistent across multiple jars to be a coincidence. Someone in 250 BC, in Mesopotamia, was working with metals, insulators, and electrolytes in combinations that we today recognize as the foundational components of electrochemistry. Whether they fully understood what they were doing, we cannot say. That they were doing it, the physical evidence does not let us deny. If you want to see the next ancient mystery that science cannot explain, subscribe, because next week I'm going to take you to the rare book vault at Yale University, where, sealed behind glass, sits a leather-bound manuscript covered in script that no human being on earth has ever been able to read. 600 years old. 240 pages. Written in a language that does not appear anywhere else, by anyone else, ever. The Voynich manuscript. I'll see you there.